On each of these three examples, the goal is to factor this trigonometric expression. So one technique that's very, very handy to know about is the difference of squares. We have two terms, and each one of these terms is a perfect square, and there's a subtraction in between. This will factor out pretty nicely. You split up the first term evenly, you split up the second term evenly, and you make sure one's positive and one's negative. So that's the case going on here. We have 4 cosine squared of theta minus 1. Now, if it helps you in visualizing this, you could maybe replace that cosine squared with an x, because I think we've all seen more factoring like this, like 4x squared minus 1. You're much more comfortable seeing an x in that spot instead of a cosine, and I understand that. But how this on the left-hand side would factor is you go 2x and 2x to make the 4x squared, 1 and 1 to make that 1, make 1 positive and 1 negative. Now it's going to follow in a very similar fashion over here on the right-hand side. This is going to split up as 2 cosine and 2 cosine to split up the 4 cosine squared. You go 1 and 1 to split up the 1, make sure one's positive and one's negative. And that's all of our factoring on this one. All right, on this next one, we have 25 minus 9 sine squared of theta. So very, very similar here. Two terms, right, separated by a subtraction. This is a difference. 25 is a perfect square. 9 is a perfect square, 3 times 3, and sine squared is a perfect square, sine times sine. So to factor this, we'll go 5 and 5 to make the 25. And then we need 3 sine of theta and 3 sine of theta to split up the 9 sine squared evenly. Then to finish this up, we just make sure one's positive and one's negative. And there we have it. We factored it. You could double check this by multiplying them back out, distributing FOIL, if you like to call it that, to double check that we get back to the original, but we will. And then one more here. Our final goal is to factor 2 cosine squared of theta plus cosine of theta plus 1. So again, if you're more comfortable going off to the side and kind of saying, well, this is like 2x squared plus x minus 1, you can factor this with x's in these same spots. You can factor this expression that has cosines. Different techniques you can go through as far as factoring this. Some of you are going to be comfortable just factoring it in your head, or guess and check or trial and error method. Others, you may want to do the AC method. So the AC method on this, you calculate ax squared, bx, and c. So you calculate a times c. So in our case, that's going to make 2 times 1 makes 2. There's only one way to get 2 because it's a prime number. So you'd use 1 times 2. And then how the AC method works is we're going to bring down the first term. You bring down the last term. But then that middle term, we're going to strategically split up using the 1 and 2. So these are going to be the coefficients as we break apart 1x. So you can say that's 1x and 2x's. But these like terms, when we combine them together, we have to end up with a positive 1 because that's the coefficient on the middle term. So we're going to have to go with minus 1 plus 2x's. All right, sure enough, if you combine these back together, you get a positive 1x. And now that we've rewritten it, so we have 4 terms, we can use factor by grouping. So the first 2 terms have an x in common. So let's factor out an x. That'll leave us with 2x minus 1 inside our set of parentheses. For a factor by grouping to work, you're going to have to end up with the 2x minus 1 inside the second set of parentheses as well. So in looking at these last 2 terms, they don't have much in common, right? But we can always say they have a 1 in common. So we're going to factor out a positive 1 from each of these. And then to finish up our factor by grouping, what's inside the parentheses goes in one of these sets. And then what's out in front, the x plus 1, goes in the other set. So that's one way we could go and factor this with all the x's. Now it could be very similar over here on the right-hand side with cosines, right? We could say 2 cosine squared of theta. And then using this exact same AC, we can split up our middle term, that 1 cosine of theta. You can say, well, we can make that 1 cosine of theta and 2 cosines of theta. and then bring down that -1, that last term. We want to make sure that if we combine these like terms back together, we're going to end up with +1 cosine of theta. So very, very similar. We're going to go with subtracting the 1 and adding the 2, right? -1 cosine of theta plus 2 cosines of theta is going to make 1 cosine of theta. Now we can do factor by grouping, where we group the first two together. This time we have a cosine of theta in common. So in factoring that out, we're going to be left with 2 cosine of thetas minus 1. And then we're going to go with 2 cosine of theta minus 1 inside this last set of parentheses also. So again, these two only have a 1 in common. We're going to say it's +1. And then to finish this up, 2 sets of parentheses. What's inside the sets of parentheses is a common factor, so that goes in one of these sets. What's out in front, the cosine of theta plus 1, goes in the other set. And if you put the cosine of theta plus 1 in the first set of parentheses and the 2 cosine of theta minus 1 in the second set of parentheses, that's equivalent, right? These are two things multiplied together. So you can flip-flop the order, commutative property of multiplication. All right, so you certainly don't have to do this both ways with the x's and then with the cosines, but it's a really, really similar thought process in both senses. I understand if you're much more comfortable seeing it with x's because you've done hundreds, if not thousands of these problems factoring with x's. Probably haven't done very many with cosines, but it really, really is the same sort of idea in both cases to help you get factored. All right, good luck.